1.3, compound interest, future value. So what's the next term in this pattern? How do you know? Those of you that took pre-calculus 20 might remember arithmetic and geometric sequences, and those that don't, that's fine too. But usually when you have a pattern, you're either adding a number to move on, or you're multiplying by a number, or you're subtracting, or you're dividing. So 100 to 150 to 225 to 375. So let's say we're adding. To go from 100 to 150, let's say I add 50. Yep. And then I add another 50, I should get 200. Okay, that's not right. So next thing I'm going to see is maybe am I multiplying? So to go from 100 to 150, let's see, if I go 150 divided by 100, it looks like I times by 1.5. Now to go from 150 to 225, do I times by 1.5? So let's go 150 times 1.5. Very good. And let's do it again. Times by 150, or times by 1.5 rather. Do I get 337.5? I do. And if I do it again, do I get this last one? I do. Okay. So the next term has to be 759.375. So I know this because the pattern is multiplying by 1.5. Okay, another way I could have written this if I wanted to get the 1, 2, so this is 1, 2, 3, 4, 5, the sixth term, I could have just gone 100 and I could have times 1.5. I'd times it 1, 2, 3, 4, 5, 5 times. 4, 1, 2, 3, 4, 5. And in other words, I could write this, a simpler way to write that is 1.5 to the power of 5. Okay, so this notation and this idea of a pattern is going to come into play with compound interest. Okay, and those of you who don't believe that this gives me the same value, I'll show you on the calculator here. So 1.5 to the power of 5. Order of operations is very important. So I do my exponents first, 1.5 to the power of 5, and then I times by 100. And I get the same value I got. Okay? Now we're going to determine the future value of an investment that earns compound interest. So Yvonne earns $4,300 in an overtime at a carpentry job. She invested the money in a 10-year Canada savings bond that will earn her 3.8% compounded annually. She decided to invest in a Canadian savings bond instead of keeping the money because will earn her more interest. What's the future value? Okay, so we know her principal. We know that her principal is $4,300. We know her interest rate is 3.8%. As a decimal, we write it like that. Okay, so let's look at year 1. So year 0 is 4,300. Year 1, we could use our formula, P plus PRT. So we take our principal of 4,300 and we add interest. So our interest is 4,300 times 0.038, and 1 year has passed from year 0 to year 1. Okay, calculating this out, I've already pre-calculated it, but if you want to grab your calculator, you can. We get 6,340. Okay, that's year 1. Now in year 2, we apply interest, but we apply it on this amount. So we put this amount into the formula instead. Times our interest rate stays the same, times 1. So at the end of year 2, now we have $4,633.01. Okay. Now year 3, we're earning interest on that amount. So A equals 4,633.01 plus the interest that I'm going to earn on that. So this is like my principal, 4,633.01 times my interest rate, and 1 year passes. Okay, and this value I get 4,809.06. Okay, so there's actually a pattern going on here. We started with 4,300. Then the next year we had 4,463.40. That's up here. And then we had 4,633.01. And then we had 4,809.06. And believe it or not, there's a pattern, and I'll show you that pattern right here. Okay, so to go from 4,300 to 4,463.40, if I use my calculator, I can tell you exactly how that happened. So let's go 4,463.4, and if I divide by 4,300, I get 1.038. 038, I think we've seen that before, haven't we? Okay, so, and guess what? If I took this value and divided it by that, look what happens. So 4,633.01 divided by 4,463.4, 1.38. Okay, and the reason there's a little more junk there is because we're dealing with cents. We've actually truncated to cents instead of more than that. Okay, and guess what? If we times that, or sorry, if we did the last one, we'd get the same value as well. So in other words, what I'm doing is I'm going times 1.38, and I'm going times 1.038 times 1.038. In other words, I could have said 4,300 times 1.038 to the power of 1, 2, 3 to the power of 3 gives me year 3. Wow, that's pretty neat. Okay, so if I wanted year 10, guess what I would do? I would go 4,300 and I would go 1.038, and instead of 3, I would put 10. Okay, using my calculator, if I did that, I would get $6,243.70. So that's pretty good. She started with 4,300, and 10 years later, she had over $6,200. Okay, so to simplify, we've actually developed a bit of a formula. Our future rate is equal to our principal times something in the brackets to the power of n, so to the number of compounding periods. So look, 0.38 was our interest, so we go 1 plus our interest rate. Okay, so this is the formula we're going to use. Couple things. Interest rate is going to be, there's something important to remember, the interest rate. It's the interest rate per compounding period. Per period. Okay, and n is the number of periods. So we were talking about annual interest, compounded annual, but you could have it compounded semi-annual or twice a year. You could have it compounded, and these are all found in the last page of the chapter, semi-annually, quarterly, so 4 times a year, or monthly, 12 times a year. Okay, so let's try an example where we do something other than annual. David has invested $1,300 in an account that earns him 7% compounded quarterly. The interest rate is fixed for 10 years. What's the future value? Okay, principal is easy. Principal is $13,000. His interest rate is 7%, but it's compounded quarterly. So we take 0.07, and because it's compounded quarterly, we divide by 4. Okay, and I don't want a decimal. I want it just looking like that. We're going to sub it in just like that. Okay, n is the number of compounding periods. So 4 times a year, 10 years, that's going to be 40 total. Okay, so this is where students mess up. They forget this part and they forget this part. People want to put 10 and they want to put 0.7, but that's not what the question's asking. Okay. So now it's just a matter of plugging into that formula. And remember that formula was A equals P1 plus I to the power of n. So just subbing in. P we said was 13,000. We have 1 plus 0.07 divided by 4 to the power of 40. Okay, let's try that on our calculator here. Oops, where does my calculator go? There it is. Okay. Order of operations. I'm going to start remember it's brackets first. And inside brackets, I have a division. So I'm going to do that division first. So 0.07 divided by 4, and then I go plus 1. And now I'm going to do my exponent. I'm going to raise that to the power of 40. Okay? And then I'm going to times that by $13,000. So after his 10 years, he has just over $26,000. He doubled his money. Okay, that's pretty cool. Last thing we have to learn, the rule of 72 is a simple formula for estimating the doubling time of an investment. 72 is divided by the annual interest rate as a percent to estimate the doubling time of an investment in years. So basically what I'm saying is how long will it take me for my money to double? The rule of 72 is most accurate when the interest is compounded annually. So better when you say annual versus quarterly or monthly. So just a quick example, how long will it take an investment of $600 to double at an interest rate of 5%? So what we do is we take 72 and we divide it by the annual interest rate. So 72 divided by 5, take out our calculator. 72 divided by 5, 14.4, so it'll take about 15 years. And we always round up because we said it was compounded annually. So we can't say 14 and a half years because it hasn't compounded yet. Okay, so roughly take 15 years. So if you have $600 in your possession right now and you can find a 5% bank account, put in the bank, after 15 years, you'll have $1,200. There you go. You can give half of that to Miss Cantillon for teaching you this. Okay, just the key ideas. This is on the last page of your chapter in your textbook, really good to look at. Again, we go through that formula that we've been using. Here's interesting. The more frequent the compounding and the longer the term, the greater the impact of the compounding on the principal and the greater the future value. So if you could compound daily and for a very long time, you're going to have more money than just compounding yearly, right? Because if you compound it daily, that's 365 times that you've got to make your interest contribute to your interest. Okay, we always want to use an exact value for I. Always sub it in as a fraction instead of a rounded value. Here's a really good, some of this language is new. So if you say semi-annual, you take your annual interest rate divided by 2. Okay, and then to get n, you go your number of years times 2. So this is a good table, a good crutch until you've got the hang of it. And it also goes into, if you just want to know the interest, you don't want to know overall how much it's worth. You want to know how much of it is interest. Here's a formula here, and it goes through the rule of 72 again as well.